We have more pictures of the Falcon 9 crater on the moon. Starship arrives at port after landing in the ocean. The Link mission to save Swift has failed. Another reusable Chinese rocket lands. And in Space Bites Plus, a really clever way to redirect an asteroid with a nuclear weapon. All this and more in this week's Space Bites. Before we get started with this week's episode of Space Bites, I just want to warn you, it's a monster, and this was not intentional. There was just so many really interesting space news stories this week. We didn't know which ones to get rid of, and so we just decided to keep them all, and it is kind of double the size in terms of stories than what we normally cover. First, let's talk about the Falcon 9 upper stage booster that crashed into the moon a couple of weeks ago. This was the upper stage that carried the Firefly Blue Ghost 1 mission to the moon. It was also carrying the iSpace Resilience lander. That one failed, but Blue Ghost made it to the surface of the moon. But now the upper stage rocket was in a declining orbit around the moon. And on August 5th, it crashed into the moon. We've got some initial images from the Korean spacecraft, but now NASA's Lunar Reconnaissance Orbiter was able to take pictures of the impact site. It's making this orbit around the moon at just shy of 100 kilometers altitude, and it tries to get every part of the moon into its eyes. And so about August 11th and 12th, it was able to cross this region and take pictures of the impact site. So here's what it looks like. And there is definitely a brand new crater there on the moon. And so you can see the impact point, and you can see that this is a fresh crater. You can see all of this bright material around the crater rim. And this is what you get when a new rock crashes into the moon, excavates this material and plops it down onto the surface of the moon. And then over millions of years, the radiation from the sun and the solar wind will discolor it and darken it like the rest of the area around it. And Lunar Reconnaissance Orbiter was able to take images of the surface from different angles as it was doing its orbit around the moon. And so that allowed it to see the crater from different perspectives. And so then astronomers were able to measure the size of the crater and the depth and the amount of ejecta, which is really cool. The crater ended up measuring about 18 meters across and about 3 meters deep, which is a pretty small crater, but human-made. And this is what geologists want to see, is that they can then examine this material that has been unearthed and use this to understand more about the composition of the top layers of the moon. I saw a lot of people very displeased with this impact on the moon. And just like keep in mind that it vaporized. So it is not wreckage sitting on the moon. It is atoms made of various materials that went into the upper stage littered across the surface of the moon. When you think about, say, the Apollo landers, those landed gently and they're still there on the surface of the moon, as well as the bags of poop that the astronauts left on the surface of the moon. On July 24th, we saw the most recent test of the SpaceX Starship. Several parts of it went well, other parts didn't go so great, but one of the really big surprises was that when the Starship re-entered the Earth's atmosphere and then made its soft landing on the ocean and then fell over onto its side, it didn't explode the way that it normally does and then sink into the ocean. Instead, it fell over and then it just floated like a boat. And so SpaceX said that they were going to try to retrieve this rocket and bring it back to port. And now, after almost a month of travel in the Indian Ocean, SpaceX has brought Starship to port. Now, they took it to one of the closest places that they could, which is Christmas Island. This is in the territorial waters of Australia. And this is not where SpaceX wants this rocket. They would really like this rocket back at Starbase, where they can really study it. So now the question is, can they bring this all the way home so that they can study it? It's one thing to have it be in a 1-month voyage on the ocean. Now you're looking at something that is going to be months and months to bring it all the way back to the US.
You're gonna need a bigger boat.
But this is critical because now you've got a rocket that flew on this suborbital trajectory, re-entered the atmosphere, and the story of what it experienced is right there on the heat shield. And this is one of the big unsolved problems in SpaceX Starship. How can you make a heat shield that can be used in a reusable fashion? So you can launch the rocket, retrieve it, launch it again, and you don't have to do this really detailed inspection of every single heat shield tile. You know that it's good enough that it's going to be able to survive multiple missions. That allows rapid reuse. And so SpaceX is going to be super interested at what happened to the heat shield of this rocket. Now, it is a write-off. Like, it was sitting in the ocean. It is not going to ever fly again. But if they can get it back to a place where they can study it, they can learn a lot about this for future iterations of Starship. One thing that's interesting is that although both of its flaps were there when the rocket landed, one of them broke off during transit and the other one has been severely degraded by the salt water. And this is what you would expect of having something that was never meant to be a boat try to be a boat for a month. So we'll see how much damage was done to the rocket. This next story comes from Lawrence Tugnetti, and he's our resident planetary scientist on Universe Today. And this is about a really cool landscape that Mars Curiosity rover found on the surface of Mars. And take a look at this. You can see this strange field of polygons. They look like hexagons, but they're not quite as well ordered as hexagons. But these are caused by cyclical mud formation. In the ancient past on Mars, say 2 to 3 billion years ago, you had a region that was getting wet and then dried out again, and then wet and get dried out again. And you've probably seen cracks in mud where you've got mud and then it dries out and then you get all these cracks forming. And then as it got wet again, material got pushed together and you got these ridges in between the join lines of all of this mud. And then cycle after cycle, wet, dry, you got this strange surface building up on the surface of Mars. And so it's cool and it's weird, but it is also indicative that there was this rapid wet, dry cycle on Mars billions of years ago. Rain was falling, then it was drying out, then rain was falling, then it was drying out. And this is a thing that Curiosity was able to see. When I saw these features, I thought about a similar feature that I grew up with on this island off the coast of Canada. We have these sandstone formations where you have this strange honeycomb structure in the sandstone. And so when I saw that, I was like, is it the same process? And then when I looked into it, in fact, it's the reverse. So the ones that I have here in Canada were caused by salt water splashing into sandstone rocks. And then the crystals were forming inside the sandstone rock and carving out these really strange holes. While on Mars, it's the mud that is building up and solidifying over time. But it's interesting, for a non-geologist to see these two structures and think they're kind of similar, but in fact, they're caused by opposite methods. Another story that we have been keeping track of is NASA's attempt to rescue the Swift Space Telescope. And this is a telescope that has been used to teach us a lot about gamma ray bursts. It's been operating for 2 decades and its altitude has gotten down to the point that it is about to re-enter the Earth's atmosphere. And about a year ago, NASA contracted a company called Catalyst to build a satellite that could rescue Swift, that could dock with it, raise its altitude back up to a place that's safe. Very short time frame. And yet, if this could work, then we could have rescues for a lot of other satellites that are on these declining orbits. And unfortunately, after Link launched, it lost 2 of its reaction wheels. It was spinning uncontrollably. They tried to recover it. And this week we got the news that they've given up. Now, they were able to recover the satellite. So they were able to use its thrusters to slow down its rotation to the point that they could actually operate it. And they're going to approach the Swift telescope, but they just don't have enough fuel left in the can to be able to perform the mission, dock, and boost the satellite like they were hoping. So they're going to do a ton of tests, learn about what it's like to maneuver in this environment near another satellite. But then in the end, Swift is going to be coming back down. It's been about a month since a Chinese company successfully landed a first stage booster. And this week we got another landing of a Chinese rocket. So this time it was a company called Landspace and their Zhuche-3 rocket booster. And it is made of stainless steel and has 4 landing legs. And so it was able to perform its mission. It was able to launch, separate from the upper stage, return back down, do its boost back burn, and then deploy its legs and land softly in the Gobi Desert. And this rocket can launch 8 tons of cargo into low Earth orbit. And they figure in their expendable mode, they will be able to get up to double digits into low Earth orbit. And so now I think you're seeing multiple companies in China, multiple organizations working on reusable rocket technology. There have been a few stumbles. It's been a hard technology for them to wrap their minds around, but now we're seeing more and more of these successes. And when you look at how China dominates the drone market, I mean, it is a very similar kind of technology. I mean, not the rocket part, but the can you control the aerial motion of something? That's what this technology is all about. And so I think we're going to move quickly from China has caught up what SpaceX has been doing for a decade, and now it's just the way that most rocket companies perform their missions. And it's really weird that Europe has not gotten onto the reusable rocket train. And hopefully, eventually, we will just see all rockets land propulsively, first and second stages. That would be amazing. All right, this next story was written by Evan Goff, and it's about how astronomers have discovered the fastest star that is orbiting around the supermassive black hole at the center of the Milky Way. And this is incredibly important, which I will get to in a second. But first, let's do some background here. So as you probably know, there is a supermassive black hole at the heart of the Milky Way, 4.1 million times the mass of the sun. And that there are a bunch of stars that are captured in orbit around this supermassive black hole. And in fact, this is how astronomers discovered the supermassive black hole in the first place, which is that they were observing these stars in infrared moving around nothing, as if they were comets moving around the sun. And that from the motion of these stars, they were able to calculate the mass of this object, this invisible object. And now we know of a lot of these stars. They all have the S designation. So this is S301, and it is the fastest moving star of the bunch. It can reach velocities of 25,000 kilometers per second. God, that's fast. The Earth is orbiting the sun at 30 kilometers per second. 25,000. The speed of light is 300,000 kilometers per second. So that is closing in on 10% of the speed of light. That's crazy. Anyway, it takes 8.7 years to complete an orbit around the supermassive black hole. And at its closest point, it's coming within 12 astronomical units. So 12 times the distance from the sun to the Earth. And that this is close enough that you can actually measure the effect of the frame dragging from the supermassive black hole as it's spinning. And this was a phenomenon that had been predicted by Einstein, but it's very difficult to find places where you can test how massive objects are tweaking space-time around themselves. You need very specific scenarios to find that, and this is one of them. And so when the orbits are farther away from the massive object, like the supermassive black hole, then you need a lot of data. You need to be making observations for years and years and years. But in this case, because the star makes such a close approach to the black hole, it's going to scream out the answers to these tests that astronomers are trying to do. And so it's just incredible. And, you know, who knows, there may be more of them orbiting even closer. And every now and then, one will just fall right into the black hole. And because it only takes 8.7 years, you can watch the entire orbit. You can watch how it's processing around the supermassive black hole, influenced by the frame dragging caused by the spinning black hole. It's just like this perfect natural experiment. Now I've got a bunch of stories about James Webb. So first up, let's talk about my favorite obsession of the moment, and that is little red dots. And just to bring you up to speed, little red dots are these objects that were discovered by James Webb. They're compact, probably in the tens of light years across, and they appear to be red. And not red today, but they were red back then. Imagine a star like Betelgeuse, but it's like 10 light years across. And we're seeing these things when they were at the very beginning of the universe, sort of between 600 million and about 1.2 billion years after the Big Bang. And then we don't see them anymore. So this was something that the universe did early on, and it just doesn't do this anymore. And so what could this be? Well, you know, the usual answer is that it has something to do with black holes, or maybe it's some kind of star. But thanks to James Webb, astronomers were able to measure the spectra of this object, and that it is not related to dust. It is more related to gas. So if it was like a big cloud of dust enshrouding a star, enshrouding a black hole, that would give off one signature. And if it's a big cloud of gas shrouding something, then that would give off a different kind of signature. And that's the kind of signature that the astronomers saw. So the problem with a star that is that big is that you just can't get nuclear fusion to operate at that scale. It would have to be 1 billion times brighter. You just can't get that amount of energy with nuclear fusion. When the energy gets too high, the fusion process starts to create antimatter and the star will just explode. So it has to be something else. And so the astronomers have proposed that you've got some kind of newly forming supermassive black hole, maybe a direct collapse supermassive black hole that is enshrouded in this cocoon of gas. And then as the black hole is consuming material, it's pumping out energy. The energy is causing the entire blob of gas to irradiate in this red color. And that's what we're seeing as little red dots. And that sort of meets all of the criteria, sort of checks off all the boxes that astronomers need to have this observation make sense. But having a direct collapse supermassive black hole early on in the universe is a tough one to explain. In fact, I did an interview with an expert in the field, Vasily Kokarev, about supermassive black holes and the state of the mystery. And I wished I had known about this and I could have talked to him about it. But we kind of covered what a little red dot will have to be. So I'm going to put a link down in the show notes so you can check that out. Next up, one big surprise from astronomers when James Webb came online was that it was finding these large early galaxies, galaxies that had a lot more mass than you would expect to see at that period in the age of the universe. And a lot of people sort of freaked out and said, like, is the Big Bang broken? Are cosmologists stumped? And it turns out that the size of the galaxies that we're seeing fit within the various models for what the universe can create. And when you consider the size and the mass of the galaxy, astronomers use this technique called the initial mass function. This is based on looking at the galaxies around us today. You look at a galaxy like the Milky Way, or maybe Andromeda is a better example, and you can measure the size of the galaxy. You can count all the stars of the galaxy of different masses, and that will tell you the mass of that galaxy. We do enough surveys of galaxies around us, and then you can apply that method to the galaxies at the beginning of the universe to try and tell you how massive they are. You see how bright it is, that will tell you how massive a galaxy it is. But the problem is that there's this idea of survivorship bias, that we are seeing the things that are really bright, but we're not seeing the things that are not so bright. One problem is that the initial mass function that astronomers use to count up the mass in galaxies today is not the same spread of masses in stars in the early universe. And in fact, they might have a lot more low mass stars that we just can't see. And so in a new paper, researchers propose this and say that in fact, they could be undercounting the mass of those massive galaxies. They could be a few times more massive than even the estimates had shown. And that again requires an explanation. Like obviously the universe figured it out, but what could have given the universe these massive galaxies so early? And like the little red dot, are they connected? Like you can see this puzzle starting to come together. And I love it. It's all connected. It's all, I need red strings behind me at this point. And then another story from Evan Goff. He's got 3 so far for James Webb. And so this one is about the first discovery of a galaxy that contains 3 supermassive black holes. Now, one supermassive black hole, that's common. Pretty much every single galaxy that we see out there has a supermassive black hole at the center. And occasionally, galaxies are found with 2 supermassive black holes. And this is the result of a merger between 2 galaxies. The galaxies mash together, the black holes orbit around each other, they find themselves at the middle of the merger, and then they combine into one larger supermassive black hole. Well, now astronomers have found a galaxy with 3 of them. The mass of these supermassive black holes, one is 80 million times the mass of the sun, one is 0.6 million, and then the last one is 2 million times the mass of the sun. 2 of them are orbiting very closely together within about 620 light years apart. And then the third one is a distant satellite. It's orbiting about 5,500 light years away from this pair. This is the result of a galaxy merger between 3 galaxies. So maybe 2 of them merged a long time ago and their black holes are finding their way to each other. And then a third merger happened, and now this new black hole has been added to the meal and is spiraling, and eventually it will join them at the center of the black hole. So this is how you get bigger supermassive black holes. And now for the next story from James Webb. This one comes from Andy Thomaswick, and this is about observations of Jupiter's moon Callisto. And Callisto is the least talked about of the Jovian moons. We talk about Io, we talk about Europa, of course, and of course I love Ganymede. Ganymede is the new Europa. But what about Callisto? Well, it's there and it's cool, and it's thought to have a subsurface ocean just like the other Jovian moons. So astronomers decided to give Callisto a little bit of love, and so they imaged it with James Webb. And of course, it's more interesting than we thought, and probably a lot more active than we originally knew. So a new paper looked at 3 perspectives of Callisto. They looked at its trailing hemisphere, the giant Asgard impact basin, and a view centered on Valhalla, which is the largest multi-ring impact structure in the entire solar system. It's like a multiple bullseye. And they found that there was a very big difference in the amount of ice crystals on the leading hemisphere of this moon and the trailing hemisphere. And of course, the leading hemisphere is plowing into the magnetosphere of Jupiter. And then on the trailing edge, they found coloration that is due to the interactions between Callisto and the magnetosphere of Jupiter. And so they think that the plasma contained within the magnetosphere is smashing into Callisto and then changing the surface depending on which side, whether it's on the leading side or on the trailing side of the moon. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that Europa's oceans can be hard to reach. So thank you everyone who voted last week. And of course, we're going to put this week's vote into the post tab here on the channel. But if you've done this before, it'll show up in your algorithm. And this is the part where I ask you to like this video and subscribe and all of that kind of stuff. And I just want to instead ask you to give a shout out to Anton, who is the editor. Not that Anton. He decided that he wanted to have 15 plus stories in this week's episode of Space Bites, even though we normally do 8. And he is probably very tired right now after completing the edit on this video, but he is a beast. And so give the video a like. And if you want, give Anton a shout out in the comments down below. I'm sure he'll really appreciate it. And the algorithm will smile upon us all. Next up, let's talk about the Andromeda Galaxy. We've got a really interesting story from Matt Williams. Andromeda is the closest neighbor to the Milky Way. It is on a collision course with our galaxy, and at some point in the future, we will merge with it, or maybe not. But right now, it's 2.5 million light years away. And so it is big enough and bright enough that astronomers are able to measure individual stars in Andromeda. And one of the things that they've realized is that it looks like star formation has been shutting down in Andromeda over the last, say, 500 million years or so. And the way they figured this out is really clever. And that is that they look at the various star-forming regions inside Andromeda, and then they characterize the kinds of stars that they see. And when you have a really big star-forming region, think about the Tarantula Nebula or the Carina Nebula that we're about to talk about. You get a really even distribution of stars in those galaxies. You get these really big, these OB stars that are big, they live short lives, they detonate as supernova. And then you have the ones that are more like our sun, and then you have all of these red dwarf stars. And so astronomers have gone and looked at the various star-forming regions in Andromeda and found that a lot of the big stars, the O's, the B's, the ones that will only live a couple of million years and then explode, they're gone. And you're left with the smaller stars. And so that means that you're not getting a lot of regions with new star formation. All you're seeing is places where star formation happened in the past. And so they figure about 500 million years ago, the star formation started to shut down. And then there was a really steep drop in star formation over the last 40 million years or so. But of course, when Andromeda and the Milky Way do reach each other, that will set off an entirely new era of star formation in both of our galaxies. But we won't be around for that. And finally, let's look at some really cool pictures. First up, this is the Helix Nebula. And this is a picture that was taken as a mosaic from a bunch of different instruments. You've got the Hubble Space Telescope, you've got a telescope at Kitt Peak, and you've got something called the Mothra Telescope. And this is a planetary nebula. This is the kind of object that our sun will become when it reaches the end of its life. It'll puff out its outer layers, it'll be left as a white dwarf, and it will have some kind of structure around it that other astronomers will be able to look at, or I guess future descendants of humanity will look at it and see this. The Helix Nebula is 650 light years away from the sun, and it's one of the biggest, brightest planetary nebulae that we can see in the sky. But where the science comes in is that when you zoom in and look at it in James Webb, you see these bow shock, you see these blobs of gas and dust that are surrounding the Helix Nebula, and then they're interacting with the interstellar winds that are then causing them to have these like little tails and trails. It's such a cool picture. Next up, this is the Carina Nebula, also taken by James Webb. And like, remember back so many years ago to when the first images from James Webb were released, one of those pictures was of the Carina Nebula, and there was the cosmic cliffs is what they called this, where you've got the combined light of all of the stars that is blasting away at this nebula material and kind of piling it up, and it looks like cliffs, but I sort of imagine it's like you're hitting with a leaf blower. This new picture shows a lot of these globules that are located in the nebula, and where they are being blasted by this radiation that I mentioned and kind of wearing them away. The Carina Nebula is the closest example of a big, big star-forming region. It's only 7,500 light years away, and yet it has all of those big, bright stars that I was mentioning in the Andromeda story. In fact, it has one of the most massive stars that we know of in the Milky Way that is probably going to blow up fairly soon, called Eta Carina. So this is just another amazing picture of the Carina Nebula. You could just blow it up and just stare at it for days. But we don't have time for that. So next up is the Lion Nebula, also known as NGC 2392. And this looks like, I don't know, a lion's mane? I see it. The nebula was imaged by the Hubble Space Telescope back in the year 2000, and now we got a new image of it from James Webb. And of course, like, James Webb just makes things look highly detailed, and this is an incredible picture. This is another example of a planetary nebula. So another star like the sun that died and puffed out these outer layers into space. And the science done with James Webb is that the astronomers are able to measure the chemicals in the nebula material around it and determine that the original star, the progenitor star, was very rich in oxygen. I hope you're enjoying this week's episode of Space Bites. And if you're watching it here on YouTube, then you probably had to watch an ad, but we don't like ads, and we actually don't have to show ads in all of the distribution channels that we control. YouTube won't let us remove the ads, but we have them on Patreon, completely ad-free. There's no ads in our newsletter. There's no ads on the Universe Today website. There's no ads in the podcast, no ads. And we've removed all the ads that YouTube will let us. But if you want to experience this episode in the no ad version, go over and check it out on Patreon, completely for free. Again, you never have to subscribe to us on Patreon. You just get to watch this video, but with no ads. And to encourage you, we put one additional story. And I think you're really going to want to watch this week's additional story. Let's imagine there's an asteroid that's about to hit the Earth. Does it make more sense to hit it with an impactor or to hit it with a nuclear weapon? The answer may surprise you. I'll put a link down in the show notes. Now, this was a lot of stories, but this is still just a fraction of the stories that we're covering on Universe Today. And of course, the best way to get them is to just stay logged into Universe Today all day, every day, nonstop. Just leave a browser window open and just refresh. But if you don't want to do that, then you should subscribe to my weekly email newsletter, which I send out every Friday. And this is just a summary of every single story that we covered this week. So if there's like one thing that you look at, just look at the newsletter. I write every word in the newsletter. It's completely free. There's no ads. You can go to universetoday.com/newsletter to sign up. All right, those are the stories that we had this week. I'm going to talk about some feedback about why someone does not recommend our channel. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bode, Carradine, Chuck Hawkins, Commander Balick, David Gilton, and David Matz, and Thralla Reading Math for Toddlers, Evan.Pro, James Clark, Jeremy Madden, Jim Burke, Marcel Smits, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Rinkaidu, Richard Williams, Sean Sargent, Stephen Filemon, Team 49, Telescopes Canada, Vlad Chaplin, Wolfgang Klutz, and Zelda Board Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I got this comment on last week's episode of Space Bites. Ultra sometimes 8908. Sorry, your level of information is just surface level, barely even touching actual science. Do not recommend. Thank you for your feedback, Ultra sometimes. And maybe this is the first time you've ever seen a video here on my channel, but Space Bites is just one of the fire hose of videos that we produce here on our channel. And yeah, Space Bites, it's right there in the name. It's space and it's bites. It's little bits of information. We have covered 15 different stories in this week's episode of Space Bites. We don't have a lot of time. We're just trying to give you the highlights of the news. And so this is not for a person who wants the science explained to them. And the analogy that I always use is if you are following a sports team, you don't need someone to explain to you what hockey is and how the pucks work and what the teams are. You just want to know what happened to your team this week. Well, Space Bites is telling you what happened to your team this week, but replace hockey players with asteroids or James Webb. But we do a lot of other content, which I think hits the different levels. So the other type of content that we do are the question shows, and that is just me interacting with the audience, and that is me just trying to figure out what you are most curious about at any one time. What is the zeitgeist of the entire audience obsessed with right now? Let's have this conversation back and forth. The third piece of content, and I consider to be sort of the bedrock and the most important part, are the interviews. And this is where I am reaching out to the actual scientist, sometimes the Nobel Prize winner or the astronaut who is in orbit right now, to talk about their science, talk about their work at a level of detail that goes beyond anything else you're going to find. And so if you're saying it's surface level, I promise you, when you listen to my interview with Dr. Adam Rees, the person who won the Nobel Prize for helping to discover dark energy, he's going to say things that you've never heard anywhere else. Or Lee Feinberg, the designer of the Hubble Space Telescope and James Webb, and now the Next Generation Habitable Worlds Observatory, he's going to say things that you've not heard anywhere else. So we've got lots of content here. Some of it is skimming the surface. Some of it is us trying to just match whatever is your curiosity, and then the stuff that goes as deep as my puny brain can handle. All right, we'll see you next week.